Welcome to the Developer Keynote. We have an exciting show for you today. And today, we'll show you how to use our agent platform to build production-ready agents. Now, I'm an avid runner, so I'm very excited about our keynote demo. Today, we'll show you how to plan a marathon, you won't have to run it, through Vegas by building an agentic marathon planner.
The role of the software developer is evolving a lot. We have to think about new ways to work. In 2026, you all are building applications in days that would have taken weeks or months just a couple of years ago. We're even doing it faster here at Google, too. And with agents, we can actually build simulations quickly to better understand the actual impact of something like a race to a city. Agent systems simulate actual behavior instead of hard-coding those behaviors or relying purely on probabilities. Our system's going to use three main agents. There's a planner that determines all the routes that we run. There's an evaluator that assesses those routes based on business and community requirements. Then there's a simulator that takes the route, creates all these actors via code, and then randomized behaviors to see the net impact to the city.
In this demo, you will see how to go from agent idea to proof of concept with our agent platform. We gave access to mapping tools using Google Cloud MCP Server for Google Maps. Here are the few lines of code that connect the agent to Google Maps MCP Server. Google Cloud MCP servers let your agent access any tools that you register. You can also use first-party tools designed and built by Google, where security is included by default. Next, let's talk about skills. We have 3 skills for our agent. Let's look at the mapping skill to see how it makes our agent an expert at using Google Maps. We also have a GIS skill in the same structure to handle geographic information. Last, we have the race director skill. Here, we have a Google Doc that our race planning committee uses to plan and check routes based on our historical knowledge of the requirements. Using Gemini, we converted that to a skill. Looks like we're done. And we can see the route rendered. The simulated route looks beautiful.
Today, we're going to show you how to move from fragile, unpredictable agentic loops to a rigorously evaluated network of experts that will literally build their own UI. I just kicked off a prompt to plan a marathon in Las Vegas for 10,000 runners. And now the planner does 2 new things: real-time evaluation to prevent agent drift in the marathon planning, and dynamic UI for instant evaluation feedback.
What we have at this point is real-time evaluation, so agents stay on track, dynamic UI, so agents render for themselves, and automatic connections using A2A and the agent registry.
Agent Platform Sessions gives us the ability to make our agents stateful over time and modify that context as needed.
The memory bank comes in to give our agents the ability to pull learnings from prior events into the context window that are relevant for a specific task, and even to store memories the agent learns for any future session.
We're going to show you how context and memory improve agent behavior. How can we bring this additional unstructured data to our planner agent?
I'm so glad you asked. I want to show how data scientists and engineers can use IDEs with their workflows. These files are stored in many different structures and file types. To make this useful, we need to chunk the documents and transform them into embeddings, which are numerical representations of the text. The planner agent can query the text and embeddings using retrieval augmented generation, or RAG. Here, I prompted the data engineering agent to create a data pipeline to manage our SQL artifacts and orchestrate the document processing from a prompt. And now, I'm using Lightning Engine for Apache Spark, an optimized engine that runs Spark lightning fast. This process reads each document and chunks it semantically using Document AI. So now, we have quickly processed the chunks and saved them into this table in AlloyDB. Let's see the chunks.
I can see the embeddings. We didn't have to create the embeddings manually.
Let's talk about 2 things here that are going to help speed up our ability to debug agentic behavior and fix our apps faster than ever. Agent Observability, which gives you visibility into operational metrics for agents based on open standards. And Gemini Cloud Assist, our agentic cloud operator that helps with managing your agents from design to run to fix to optimize.
We will use Agent Observability and the Cloud Assist Investigations agent to dig into a simulation agent error on agent runtime. We will find and isolate the root cause of the error. Then we will deploy a proactive fix, all with natural language. Let's figure out what's happening under the hood by opening the agent runtime trace view. Now, traces allow us to see the agent's underlying tool calls and reasoning flow. Now, here's what I really love about using agents during the debugging process. They don't just find the root cause of the issue. They suggest a proactive code fix to patch the issue. Google Cloud uniquely provides a full observability suite for your agents. Cloud Assist and your coding agent don't just identify issues in these systems. They proactively fix the problems that they find.
I want to show you an example of vibe clouding, where we use the power of agents to upgrade an existing system. Now we plan to use Cloud Assist to modify infrastructure as code. We'll do the runtime conversion and Gemma deployment in a single prompt. Convert this Cloud Run service to the equivalent on GKE with the Gemma 4 model hosted in the same cluster. Cloud Assist serves as the translator that turns my intent into infrastructure changes. We see a world where agents work with you to take action within the guardrails you set, not just answer questions you have. Partner with me to safely implement change. This is our vision of an autonomous cloud.
So let's show you why, as developers, no-code agents can be really a powerful tool in your tool belt. And we'll show you how high and no-code agents work together.
Here we are in Gemini Enterprise's Agent Designer. We've given a prompt to Gemini Enterprise to create an agent that is an expert at planning and ordering for a race, using this prompt here.
So we have the main agent, which coordinates all the planning and ordering with a team of sub-agents that are experts in their specific area. So let's give the agent access to our document about ordering supplies as context. And we just need to provide it with the Google Drive link. Here, we simply give the document as context to the agent and always has access to the up-to-date information. This is high-code and no-code agents working together for us to make race planning easier.
We always talk about shifting left for development, but that's hard, and security is never a lot of fun for devs. Let's be honest, shift left is often code for. Developers should just do more. We need to shift down instead. That means smarter platforms. We need to provide better ways to give conditional access from agents to humans and agents to agents.
Agent identity gives agents well-defined policies to help ensure that agents can access only what they need, only when they really need it, and nothing more. And Agent Gateway, which gives teams a centralized place to manage all of these policies together.
I'm going to show you how to govern agents with easy-to-understand policies. You'll also see how to identify exploitable risks in your code and how to fix them. The Planner agent is communicating through the Agent Gateway, and thanks to our new policy, it can no longer call write-enabled tools on the Finance MCP server. And there we have it. In just a few steps, Agent Platform has enabled us to implement role-based access control for our agents using agent identities and policies.
Wiz is a unified cloud security platform that helps organizations secure everything they build and run. This is a full architecture, so while you were building your app, security can easily see what you've built, understand it, without you having to actually explain it to them. So we can see also not only the agent is here, but also there is a full attack path from the internet through this internet exposure all the way to sensitive data. Now, the Wiz Green agent looks at this attack path, and it actually suggests 3 priority fixes to break the attack chain. Voila, basically code findings turned into actionable code fixes, grounded in runtime exposure and actual attack path context.
It's exciting to see how Gemini Enterprise Agent Platform can empower developers to build production-ready agents.
I'm so excited every developer in this audience can try out the app we built right now, but check out the developer solution we've created for this project. It actually guides you through the architecture, how we built the various pieces of this using Google Cloud, and we even provide links and cloud credits to all the labs that we've built so you can try it yourself. If you remember nothing else, though, our agent platform makes the process of building and running these agents the best in any cloud. From the runtime with Agent Cloud, to giving our agents memory and context with our Data Cloud, and the code and frameworks with ADK, and Agent Platform's built-in AI services for tracing and eval.
Now let's go build.